Okay, question 3. Welcome to Let's Get to the Marks. Benzoic acid can be prepared from ethyl benzoate. Ethyl benzoate is first hydrolyzed in alkaline conditions as shown. So we've got a benzoate molecule here, which is an ester, plus sodium hydroxide, and that is going to form sodium benzoate and ethanol. A student used the following method. They added 5 centimeter cubed of ethyl benzoate with a density of 1.05 gram per centimeter cube. Notice I'm making a note of the data because I'm obviously going to get a calculation on all these numbers later. So I'm putting those to the side. So we know that we had 5 centimeters of ethyl benzoate, which has a density of 1.05 gram per centimeter cubed with an MR of 150. Now, this was added to 30 centimeter cubed of 2 mole per decimeter sodium hydroxide in a round bottom flask. Add a few anti-bumping granules, attach a condenser to the flask, heat the mixture under reflux for an hour, allow the mixtures to cool to room temperature. Pour 50 centimeters of 2 mole decimeter hydrochloric acid into the cooled mixture. Filter off the precipitate of benzoic acid under reduced pressure. Suggest how the anti-bumping granules prevent bumping during reflux. So anti-bumping granules break up large bubbles that are created when you boil a liquid that could potentially be explosive or crack your equipment or cause your equipment to fall over. They stop them bubbling so violently by creating smaller bubbles. So they only allow small bubbles to form and no large bubbles. 3.2, show by calculation that an excess of sodium hydroxide is used in this reaction. So we need to show that sodium hydroxide is in excess. So what were our two reactants? Our two reactants were ethyl benzoate, in which we had 1.05 gram per centimeter cubed, MR150, and 5 centimeter volume. And we had sodium hydroxide 30 centimeter, 2 mole per decimeter. So the fact that we've been given density means we're going to need to use density equals mass over volume. So 1.05 grams is the density, 5 centimeter cubed is the volume. If we do D times V, we get M, which is 5.25 grams. So now we know the mass of ethyl benzoate. We can now combine that with its MR in the equation mass over MR equals moles and do 5.25 grams over 150 MR, and that is going to give us 0.035 moles of ethyl benzoate. That's how much ethyl benzoate we had, which was our first reactant. We now want to see prove that sodium hydroxide was in excess in this reaction. So we do N over CV because this time we've been given volume and concentration. We've got 30 centimeter cubed, but remember in A-level chemistry, you've got to divide 30 by 1,000. You've got to turn centimeter cubed into decimeters. So we're doing 2 times 0.03 decimeter cubed, and we're going to get 0.06 moles. So it's quite clear to see that sodium hydroxide is in excess because we've got 0.06, which is bigger than 0.035. Now, if you wanted to know how much sodium hydroxide is in excess, well, it's a 1-to-1 ratio. So 0.06 moles of sodium hydroxide, you're going to use up 0.035 and be left over with 0.025 moles of sodium hydroxide in excess, and that's what you're going to be left with afterwards. Okay, groovy. This will have proved and got you 2 marks. Let's move on to the next part of this question, which is 3.3. Suggest why an excess of sodium hydroxide is used. So why did they use extra sodium hydroxide? Well, this is to ensure that all of the ethyl benzoate reacted completely and is all used up. You haven't left any behind. Okay, we want to get the maximum yield we can achieve. And so we need to use up all of the limiting reactant. And so we use a lot of extra sodium hydroxide to ensure that all the ethyl benzoate is completely reacted. Suggest why an electric heater is used rather than a Bunsen burner. Think about a Bunsen burner. It's got a big flame coming off of it. Esters, like ethyl benzoate, are flammable and they're volatile. That means they vaporize. At room temperature, you're going to get some vapor coming off, and that vapor would catch fire if it touched a naked Bunsen burner flame. So an electric heater is you're going to heat in a more even manner around the bottom of a round bottom flask. State why reflux is used in this hydrolysis. Reflux is where you have the condenser vertically above the round bottom flask. And what that means is any vapors of reactant go up into the condenser, they condense to liquid and they drip back down into the reactant mixture, and you don't lose any of your vapors, they don't escape. So you keep doing the reaction until all the reactants are used up. You're ensuring that all the reactants are used up and none of the reactants escape. You want to complete the reaction fully. So that's going to get you the mark there. Now, 3.6, write an equation for the reaction between sodium benzoate and hydrochloric acid. So let me zing up to the top here and just look at my sodium benzoate. How many carbons have I got? 1, 2, 3, 4, 5, 6. Oh, and we've got the one with the carboxylic group coming off there, and 2 oxygens and a sodium ion. Yeah, that's easy enough. Okay, so we want to do the reaction of that molecule with HCl. So C6H5 COONA instead of an H. It's not like benzoic acid. It's just got a sodium instead of that final hydrogen on the hydroxide group. Add it to hydrochloric acid. We're going to get a sodium chloride and we're going to get benzoic acid formed. C6H5COOH. There we go. Suggest why sodium benzoate is soluble in water, but benzoic acid is insoluble in cold water. So this one's difficult. I think this was very hard to get the 2 marks. But if you look at the formula for sodium benzoate, so notice that the oxygen has a negative and the sodium has a positive. This solid sodium benzoate is actually an ionic compound, and we know that ionic compounds are always soluble in water. So ionic compounds are soluble, so that gives us our first mark. However, when we look at benzoic acid, it's not ionic, it's a covalent compound, but it does have a polar bond. It's got that hydroxy group on the carboxylic acid. You might say, well, doesn't that mean it can hydrogen bond with water? It all depends on how big the non-polar region is compared to the polar region that can hydrogen bond. And in this molecule, benzoic acid, the benzene ring, what's a benzene ring got, like 76 or is it 78 MR? So it's a massive part of the molecule is the benzene ring, and it's non-polar. The electrons are evenly spread. So you've only got this tiny little part of the molecule that can hydrogen bond, and a vast large part of the molecule is non-polar and cannot form hydrogen bonds. So that's the reason why it's not soluble in water. And I think that was the harder mark to get. After the solid benzoic acid has been filtered off, it can be purified. So we can purify our solid product. Describe the method that the student should use to purify the benzoic acid. So first of all, we want to dissolve it in a hot solvent like ethanol or water, because we said it's ionic, so it can dissolve in water. So we're going to dissolve it. We want to use the minimum amount of solvent possible so the solution is fully saturated with the benzoic acid. So we get it completely saturated like that. And then what happens is, while it's still hot, it's important we don't let it cool. If we let it cool in the filtration process, if we let it cool, then some of the benzoic acid will immediately start to recrystallize, and we're going to filter that off and lose it. So we want to filter when the solvent is hot, and this will leave behind anything that didn't dissolve when we first dissolved it in hot ethanol and water, and we get rid of those. Those are the insoluble impurities. So we want to get rid of insoluble impurities. Now that we've got rid of the insoluble impurities, we can cool to recrystallize and reform the solid benzoic acid. Now we've got rid of all the insoluble impurities. So all we need to do now is filter under reduced pressure, which will get rid of any of the solvent that's clinging to it. So we're going to filter that all off, and now we finally just wash with a cold solvent just to remove any soluble impurities that are on the surface, and then dry. And that's your 6 marks. And you can dry in air or you can dry with a vacuum pump. Okay, 3.9. In a similar experiment, another student used 0.04 mole of ethyl benzoate and obtained 5.12 grams of benzoic acid. Calculate the percentage yield. There's a couple of ways you can do this. You can do this by doing actual moles over the maximum amount of moles produced times 100, or you can do it as actual mass over the maximum mass, theoretical mass of product produced times 100. So I'm going to use the moles method. So what have we got? We got 0.04 moles of ethyl benzoate. And as it's a one-to-one reaction with the ethyl benzoate to the benzoic acid, it was one-to-one when we look at the equation. This means that I should make 0.04 moles of benzoic acid. So 0.04 moles should be, he says, should be how much benzoic acid you make. So that can go, 0.04 can go underneath as my maximum. What I need to do is now find out how much actual we made. We obtained 5.12 grams of benzoic acid. I've worked out that MR of benzoic acid is 122. So I do 5.12, which is mass, over MR, which is 122. And that gives me 0.0419. Going to round that up to 0.042. You can see something strange is going to happen here. We're going to get the impossible result of 104.9% yield. So we actually made more than was physically possible. So what's the mistake? What's the suggestion? What's happened here? Think about the method. What went wrong with the method? That means we ended up with a greater amount of product than was chemically possible when looking at the coefficients and the amounts. So what do you think went wrong? Well, maybe when we dried it, we didn't dry it fully and there's still some water clinging to it right at the end when we air dried it, and that H2O which we used to wash it right at the end is adding to the mass of our product. So instead of 5.12 grams, maybe it was only 4.98 grams and we had a little bit of water added on the end as well. Or maybe when we dissolved it in the hot ethanol, there were still some impurities that we didn't fully remove and they're contributing to the mass. All right, guys, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.